How does COP work for designing HVAC systems? Have you ever wondered how heating and cooling systems are rated for efficiency? One important factor is the coefficient of performance, often known as COP. This metric plays a vital role in designing HVAC systems. It helps engineers determine how well a system converts electrical energy into heating or cooling output. The coefficient of performance is defined as the ratio of useful heating or cooling output to the electrical energy input required. For instance, if a system has a COP of 4, it means it provides for units of heating or cooling for every 1 unit of electrical energy consumed. The higher the COP, the more efficient the HVAC system is at transferring heat. COP is applicable in both heating and cooling modes, but it is most commonly used to describe the performance of heat pumps. While cooling efficiency is often expressed using the energy efficiency ratio, COP can measure both heating and cooling. Since COP is a ratio, it has no units, as both output and input energy are expressed in the same units, typically kilowatts. When designing HVAC systems, engineers use COP to select equipment that meets energy efficiency goals. Systems with higher COP values consume less electricity for the same heating or cooling output. This leads to lower utility bills and a reduced environmental impact. It is essential to note that COP values depend on specific indoor and outdoor temperature conditions. These conditions can vary, making it difficult to compare COP values from different manufacturers or climates directly. To address this, the seasonal coefficient of performance is used. This averages performance over a typical heating season, providing a more realistic measure of efficiency for various climates. Calculating COP for heat pumps involves comparing the heat output from the condenser to the electrical power input to the compressor. The formula is simple. COP equals heat output in kilowatts divided by electrical input in kilowatts. This relationship shows how effectively the system moves heat instead of generating it through direct electrical resistance. This is why heat pumps can achieve COP values greater than 1, often ranging between 3 and 5 under favorable conditions. In summary, the coefficient of performance is a fundamental parameter in HVAC system design. It quantifies the energy efficiency of heating and cooling equipment. Selecting systems with high COP values is essential for energy-efficient building climate control, cost savings, and sustainability. Understanding COP allows mechanical engineers to optimize HVAC system performance according to specific application requirements and environmental conditions.